As we're looking at introducing statistics, it's important to differentiate between the population and the sample. So the population is that large collection of entities for which we have an interest at a particular time. If I'm looking at marketing research, then that population of interest might be all of the potential customers who might buy my iPhone, right? So that could be people across multiple countries, multiple age ranges. It might be a certain income level that defines that population. And then if we're going to collect information, we're collecting information not from everybody. If you're collecting information from everybody in the population, you have what is called a census. So for example, when Canada or the US does a census every 10 years, they're actually collecting information from everybody in the US or everybody in Canada. So a census collects information from everyone in the population. Well, if you're doing marketing research, even if you're Apple with lots of money, you're not going to collect information from every potential person who could buy an iPhone anywhere in the world, right? So you're going to collect from a subset of the population, a sample. So it's going to be a smaller group, and ideally you want that sample to be representative of the population. And the reason is, if we go back to our little image from the very beginning, is that we are pulling information from that sample so that we can understand the greater population. So if our sample isn't anything like the population, then we're wasting our time and money to do this, because it's not going to tell us anything about the greater group. And we're taking a sample because we don't have access to that entire population. It's cost prohibitive to contact everyone. It would take so much time that by that point, the decision we're trying to make is irrelevant. So we take a sample, we try to get it to be similar to the population so that we can understand the population, but not have the time and the cost that comes with having to contact everyone in the population. So sorry, let me just go back here. Okay. And when we take our sample from the population, we want to have it be representative. And in a previous video, and I encourage you to go back to it, look at different sampling methods. So when we're doing our research design, we talked about sampling methods. We had ones that were representative or probability samples. And we had a simple random sample where everyone has an equal chance of being selected from that population. We had stratified sampling where we are looking at representing certain characteristics of the population. So if we have certain income brackets we want to represent in the sample, we would then randomly select from those different groups. That's stratified sampling, again, trying to represent the greater population, and they're making sure that key information or characteristics are appearing in the sample as well. With cluster sampling, what we would do is when we have a large geographic region, we don't necessarily want to make sure that each region is represented, because that would be the stratified sampling, but instead we want to make sure that we represent the variability of the geographic regions by randomly selecting locations and then randomly selecting people within those locations. So that's our cluster sampling. So there are different types of probability or representative sampling, and we have a video on that, and we covered that in our research design. We also have non-probability sampling. That's when the sample doesn't truly represent the population. We need to make sure that we outline and explicitly state that we have that. We might do that because we just can't get access to a representative sample. And so that limits us in that ability to extrapolate about the greater population. We recognize those limitations and we mention those in any recommendations that we create. So the reason we're talking about population and sample here is because we want to get into the idea of parameters and statistics. So as we start to summarize information about the sample, and we want to extrapolate and say things about the greater population, we need to specify whether that summary statistic, like an average, is about the sample or is about the population. So a statistic is some summary of the sample. So we would have the sample mean or the sample standard deviation. That's different from the population mean or average or population standard deviation. So we call one a parameter being that summary about the population, and a statistic being a summary about the sample. So when we look at population versus sample, right, in each situation we explain whether it be more appropriate to treat the observed data set as a sample or a population. So if you're a historian, you're summarizing the ages at death for all past presidents. Is that sample or population? Well, if everyone is included in your study, so every president you have data on, it is a population. And so if you are saying, here's the average death, here's the maximum death, here's age at death, here's the minimum age at death, those types of summaries are parameters because they are about the population. A nutritionist wants to determine which of two weight loss programs is most effective. He assigns 25 volunteers to each program and records the participants' weight loss after 2 months. There, it's a subset. We're collecting information on just 25 volunteers. We hope that those volunteers are representative of the greater population. And so when we look at average weight loss over the 2 months, that's a sample statistic. Okay, so we need to be able to distinguish between a parameter and a statistic. All right, so can you identify whether the following are parameters or statistics? So in the 2000 census of the US, it was determined that the average household size was 2.59 persons per household. Is that a statistic or a parameter? Remember, a census means we collect information about everyone. So that is going to be a parameter. An ABC News poll done in 2004 found 36% of 500 persons surveyed said they supported replacing the portrait of Alexander Hamilton on the US $10 bill with Ronald Reagan. Okay, parameter or statistic. Now, parameters and statistics can be averages, can be minimums, can be maximums. They can be proportions. They can be percentages is what you see here. And here it's 500 people we're hoping represent the greater US. And so we have a sample statistic. To estimate average normal body temperatures of all adults, a doctor measures the temperature of 100 healthy adults. The average temperature for that group is 98.2 Fahrenheit. Parameter or statistic? It is a statistic, right? It's a subset. 100 healthy adults we're hoping represent all healthy adults in order to extrapolate and say, okay, what is the average temperature for the greater adult population?